Seeing as how there's only one person watching, uh, I'm just going to go through this, and as you have questions, you can ask. And I'll try and explain it as I go. This is a different practice quiz, by the way. Um, the other practice quiz that we went over, you can actually, it's up, it's posted. And I did a review on it on Sunday. So it'll be up just in the list of videos, and you can go back and watch that if you want to. Um, Besides that, this is just a different one that I just regenerated. Uh, Again, ask questions as I go. Okay. So these first couple is just about the one-to-one property. And what the one-to-one property says is that if you have the same base on both sides, you can basically just cancel out the bases and set the exponents equal to each other. All right, so the left-hand side on this is 6 to the negative second, and that is taken to the power of x. It is a negative 2 because the 36 is in the denominator. And then 216 is 6 cubed. And that is being taken to the 2x minus 2 power. So then we can simplify these exponents a little bit because this is a power to a power. This is really 6 to the negative 2x. And this is 6 to the power of 6x minus 6. And now that the bases are the same on both sides, we can cancel them out and set negative 2x equal to 6x minus 6. And then if we add 2x to both sides, or I'll subtract 6x. So negative 8x will equal negative 6. So x will equal 6 over 8. Same thing on number 2. We want the same base on both sides. So 4, we're going to leave 4 here. And 1 over 16 is 4 to the negative 1. Negative 2, sorry. Because the same base is on both sides, we can cancel those out. So negative n will equal negative 2. N then will equal just positive 2. On number 3, 81 and 1 over 9 have a common base of 9. So we can rewrite 81 as 9 squared. So the negative 2n. And that equals 9 to the negative first to the power of 3n. Hello, Seth. Then when we simplify these exponents, this is 9 to the negative 4n is equal 9 to the negative 3n. Cancel those out. Negative 4n equals 3n. Add 3n to both sides. So you get negative n is equal to 0, so n will equal 0. The fourth one is very similar to the first. So we're going to leave 6 to the 2n minus 1 alone. And 216 is 6 to the third. Same bases on both sides, so you use the one-to-one property, cancel those bases out. So 2n minus 1 will equal 3. It's the same length as the practice quiz. You can find the original practice quiz in On Campus, but it'll be 16. All right, add 1 to both sides, 2n is equal to 4, n then is equal to 2. Yeah. Number 5 through 7 is where it starts to get a little bit different. So 10 and 50 don't have a common base. So because they don't have a common base, we have to use some other function to get negative 6r by itself. So in order to cancel out a base of 10, you need to take a log base of 10 on both sides. And because you do it on the left-hand side, you have to do it on the right-hand side. Because 10 to the power of something and log base 10 are complete inverses, those cancel. So you're left with negative 6r is equal to log base 10 of 51. And then divide both sides by negative 6. So r we equal log base 10 of 51 divided by negative 6. Yes. Yeah, I'll do it once we finish this. But again, both like you can kind of scroll through the videos and the answers will be there. So if you absolutely need it, like right this second, I would just do that. But I will post the answers. I think the practice quiz answers are actually still there, the original. That was the one that was done on Sunday, but that's in on campus already, and it should have all the answers on it. That's chapter 3 material in on campus. Okay, number 16. Number 6. Again, 18 and 43 don't have a common base, so in order to get rid of this base of 18, we have to take a log base of 18 on both sides. When we do that, this log base 18 cancels this 18, and we're left with negative 10x. Then you divide by negative 10, so x will equal log base 18 of 43 divided by negative 10. So 5 and 6 are like the basic versions of that. Number 7 is just one step further. So I always look at number 7 as 7 times some unknown is equal to 92. Okay, so if you had 7x is equal to 92, the first thing you would do is divide by 7. So then you have to do that here as well. So 13 to the negative 7x will equal 92 divided by 7. And because those two don't have a common base, again, we have to take a log base 13 of both sides. When we do that, the log base 13 and this 13 cancel. So we're left with negative 7x. And then divide both sides by 7. So x will equal log base 13 of 92 divided by 7 all over negative 7. So those are like the solving exponential problems. It's using the one-to-one property and then using the inverse property in order to get exponents by themselves and then solving using algebra, which sounds like a lot. Really, you're just taking a log of a base and then solving. The next couple, so 8 and 9, we are condensing. So we're using the product property, the power property, and the quotient property, which I will write. So if we have a product of two or more things inside a log, then we can split that up into two separate logs and add them together. So that's the product property, and you should be able to work both ways on that. You should be able to work from left to right and right to left. The quotient property is kind of the same thing, except instead of a product of two things on the inside, you have a quotient. So if you have something divided by something else inside a log, you can split up that log into two different logs and take the difference between them. And then the power property if you have an exponent on the inside of a log. So say you have log of x to the power of a, you can take that exponent and put it out front. So it's just a times log base x. Okay, so we're using these three properties on numbers 8 and 9, and really number 10 and 11 as well. So in number 8, we have 5 times log base 7 of x minus 6 log base 7 of y. The first thing we need to do, kind of like order of operations, we need to take care of exponents first. Okay, so these two numbers, 5 and 6, those are exponents of x and y respectively. So if we condense those parts, we get log base 7 of x to the 5th minus log base 7 of y to the 6th. And then we can worry about the product and quotient property. Okay, now because there's a difference here, you're just taking the quotient, or the ratio of x to the 5th over y to the 6th. And you're putting that in one log. I've seen a lot of people do this where they put log base 7 of x to the 5th over log base 7 of y to the 6th. That is not right. Okay, it's just one log and a quotient on the inside of the log. Same thing here. This 5 and this 3 become powers of a and b respectively. So if we just condense that part, log base 3 of a to the 5th plus log base 3 of b cubed. And then once we have that, we can use the product property. So this becomes 1 log of a to the 5th times b cubed. On number 10 and 11, instead of working from left to right on these properties, we are working from right to left. So number 10, I'm just going to rewrite this a little bit for you. So if we have this, if we have the square root of xyz, that's really xyz to the 1/2. So we can use the product or the power property with this exponent. So our new log becomes 1/2 log 6 of x, y, z. And then we can use the product property to expand that just a little bit further. Okay, so this becomes 1/2 log 6 of x plus 1/2 log 6 of y plus 1/2 log 6 of z. And the reason each one of them has 1/2 is because this 1/2 distributes to each of them. Similar on number 10 or 11. In order to undo it, we're going to take the quotient property first. If you keep the exponents under the square root, I mean, the square root of something is that something to the 1/2 power. I probably won't give you something like that because it's going to confuse too many people. But xyz, the square root of xyz is xyz to the 1/2, which is x to the 1/2, y to the 1/2, z to the 1/2. So is that really wrong? I don't think. I'm not really exactly sure what you're asking. But that's how I would do it, just to make it simpler. So after we use the after we use the quotient property, then we can use the power property. So this exponent comes out front and this exponent comes out front. So it's 3 log x minus 4 log y. And then the rest is using both the one-to-one property with logs and then using the one-to-one property with logs and the properties. Okay, so number 12, because there's a log base 6 on both sides, in a way, they cancel. So we're just left with a plus 8 is equal to 2a minus 10, and then solve that. So if we add 10 to both sides and subtract a from both sides, we get a is equal to 18, and then we're done. Same thing on number 13. Because there's 2 natural logs, one on each side, they cancel each other out. So 4x will equal 5x minus 6. Subtract 5x from both sides, so negative x will equal negative 6. So x will equal 6. So those are the 2 easier ones. The next 3 require both the one-to-one property and the product, quotient, and power property. Really, in this case, just the quotient and power and product property. Okay, so number 14. The first thing you have to do is you have to condense the left-hand side. Okay, so if we condense the left-hand side, we get log base 3 of 5 divided by x plus 2, right, because of the difference. So there's a difference of 2 logs with the same base. So we take the quotient of the 2 things inside the logs. And that's still equal to 4. Okay. Then, in order to cancel the log base 3, we have to take, well, basically everything you see here becomes an exponent of 3. Okay. So we get 3 to the power of log base 3 of 5 over x plus 2 is equal to 3 to the power of 4. Again, everything on this line becomes the exponent of 3 on this line. When you do that, the 3 to the power of log 3 cancel. So you're left with 5 over x plus 2 is equal to, I think, 81. Then we multiply by x plus 2 on both sides. So 5 is equal to 81x plus 162. So then negative 157 is equal to 81x. X is equal to negative 157 divided by 81. So that seems a little bit harder when it gets to the very bottom point. But these top two lines we should be able to get. These bottom two really aren't that hard. It's just bigger numbers. That's why it seems harder. Number 15, it's very basically the same thing. We have to condense the left-hand side. So when we do that, we're using the quotient property. So we get log base 3 of 7 over x minus 2. We want to get rid of the log base 3, so we have to take all of this as an exponent of 3. So when we do that, we get 3 to the power of log base 3 of 7 over x minus 2 equals 3 to the third. This 3 and this log base 3 cancel. So we have 7 over x minus 2 is equal to the just 27. Multiply by x minus 2 on both sides. And then solve like normal. And then same thing on the next, on 16, except we're not using the quotient property, we're using the product property. So when we condense the left-hand side, we get log base 7 of 24x squared is equal to log base 7 of 6. Because you have a log base 7 on both sides, they cancel. So 24x squared is equal to 6. X squared is equal to 6 over 24. So x squared is equal to 1/4. So then x is equal to 1/2. Or negative 1/2. But I would at least expect you to get here. So are there questions on any of that? Are there any that you straight up did not understand? Would anyone be interested in me doing another one of these? If you have the same base on one side, but it's added and not subtracted, so like number 16, when you're adding, you're using the product property. So you're multiplying them together inside parentheses, which is exactly number 16. I think that's what you're asking. I'm not 100% sure. I will do another one of these, but I'm going to need like 2 minutes to actually get it from my laptop. So give me a couple minutes. I will email myself another version of this, and then we can do that from start to finish. So 2 minutes. And I will be right back. All right. So again, as I do this, I'll try and slow down just a little bit so you guys can actually ask questions as I go. There's like a 10-second delay between me actually doing this and your responses, so that might be why it sounds like I'm going really fast. Um, but just ask as we go. The first three or four or so, I don't think we'll have a problem, but once we get to five, six, seven, and so on, I'll try and slow down just a little bit. Yeah, I'm sorry. Um, so numbers 1 through 4 all involve the one-to-one property. So you're trying to get the same base on both sides so you can cancel them and then set the exponents equal to one another. Okay, so that's all we're doing for 1 through 4. All right. So on each of these, we need to find a common base. All right, so a common base between 4 and 64 is just 4. So we're going to keep the left-hand side the same and then rewrite 64 as a base of 4. Okay, so 4 times 4 is 16, times 4 is 64. So that's 4 cubed. Once we have the same base on both sides, they both cancel. So negative k is equal to 3. So k is equal to negative 3. Same thing on number 2. We need a common base between 1/9 and 1 over 81. So I ignore the numerator first, and then we can factor that in here in a second. So 9 is just 9 to the first. 1 over 9 is 9 to the negative 1. So we can rewrite 1/9 as 9 to the negative first, and that is taken to the power of 3p. 81 is 9 squared, and because it's in the denominator, it has to be a negative exponent. So 1 over 81 can be rewritten as 9 to the negative 2. Then we have to simplify those exponents. All right, so when we have a power of a power, we're multiplying. So this left-hand side becomes 9 to the negative 3p. And then the right-hand side stays the same. Because both sides now have a common base, they cancel each other. So then we're left with negative 3p is equal to negative 2. When we divide both sides by negative 3, we get our answer. I'll just make them bigger. Yes, I will. I'll give it a second for people to ask questions on these first two, and then I'll make this entire thing bigger. It's just going to distort the writing. Is that better? Yep. All right. 3 and 4 are exactly like the ones we just did. So we're trying to get the same base on both sides. So, and this is a little bit trickier and it takes a little bit of practice. A common base between 49 and 343. 49 is a perfect square of 7 and really nothing else. So it has to be 7. All right. So we can rewrite 49 as 7 squared. And that's being taken to the power of negative n minus 2. When we multiply 7 by itself, grab my calculator. So 7 times 7 is 49, times 7 is 343. So 343 can be rewritten as 7 cubed. And that's being taken to the power of negative 2n. Then we have to simplify those exponents. So when we have a power, we multiply. So this is really 7 to the negative 2n minus 4. And the right-hand side is 7 to the negative 6n. Because both sides have the same base, they cancel each other out. So we're left with negative 2n minus 4 is equal to negative 6n. Add 2n to both sides. You get negative 4 is equal to negative 4n. So n is equal to 1. Same thing for number 4. We need a common base between 2 and 64. So it has to be 2, because 2 is the only base of 2 that is a perfect square. All right, so 2, the left-hand side is going to stay the same. And then we need to rewrite 64 as a base of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's 2 times itself 6 times. Then we have the bases are equal to each other, so they cancel out. So we set the exponents equal to each other. And then the rest is just algebra. All right, so subtract 2 from both sides. You get 2a is equal to 4. Then divide by 2 on both sides. So a will equal 2. So these first 4 should honestly be easy points to get. All right. So long as you can see one common base, you should be able to do it. All right. Are there any questions about those first 4? Okay. The next couple, the next 3, the fraction one. Oh, number 2. What about number 2? So 1/9 is 9 to the negative first. And 1 over 81 is 9 to the negative second. And once you get that, the rest is algebra. And then this is your answer. Yeah. Do you want me to re-explain it, or are you good? All right. Okay. On number 5, 6, and 7, both of the sides don't have a common base. All right, so when you can't find a common base, and really you could do this for all these first four, but it would make your life just a little bit harder. When you don't have a common base on both sides, you need to cancel out the base with the unknown attached to it. Okay, so we're trying to get p plus 6 by itself. So in order to do that, we need to take the inverse of an exponential function with a base of 4. So the inverse of an exponential function with a base of 4 is a log with a base of 4, because the logs undo exponentials. All right, so we're going to take the log base 4 of both sides. And the reason we do that is because the log base of 4 on the left-hand side will cancel out the 4 on the left-hand side as well. Okay, that's like multiplying by a fraction or adding a negative. They undo one another. So when we do that, this log base 4 and this 4 cancel. And according to the power property, this p plus 6 really comes out front. So this is p plus 6 times 1. So we're just left with p plus 6. You don't have to remember all that. That's just what's happening. Okay, and the right-hand side stays the same. And then you treat log base 4 of 71 kind of like a variable. All right, so when we subtract 6 on both sides, we put the negative 6 outside of the parentheses. Okay, you can't put it in the inside of parentheses, because when you do that, what you're really doing is something with 4 to the power of negative 6, which you can't do because that goes against order of operations. And then the same is true for number 6. All right, there is no common base between 7 and 29, so we need to cancel out that base of 7. In order to do that, you want to take the log base 7 of both sides. And again, the reason you do it on the right-hand side is because what you do on the left-hand side, you also have to do on the right-hand side. Okay, and just like in number 5, when we take the log base 7 of 7 to some power, what's left is just the exponent up top. So this log base 7 and this 7 cancel, and we're just left with k minus 3. Then you add 3 to both sides, so you get k is equal to log base 7 of 29 plus 3. And then this is your answer. So questions about those two? All right, I'm going to move on then. The 7, why is the 7 gone on number 6? Okay. So in order to undo, I'm going to do this in a different color so you can see what I'm talking about. In order to undo this 7, you have to take the log base 7 of both sides. When you do that, you have log base 7 of 7 to the k minus 3 is equal to log base 7 of 29. The log base 7 and this 7, they cancel each other out. So you're just left with the exponent. So you have k minus 3 is equal to log base 7 of 29. Add 3 to both sides. You get log base 7 of 29 plus 3. Does that answer your question? All right. So number 7. Uh, number 7 is really just one step harder than the last two that we just did. All right. Um, so I always think of these problems as this box plus 6 is equal to 35. All right, so if this question were really just x plus 6 is equal to 35, the first thing that you would do is subtract 6. Okay, so then you'd have x is equal to 35 minus 6, which is 29. All right, you do the same thing in this actual equation. So you leave 2 to the power of negative 9a by itself. You leave that alone. Subtract 6 from both sides, and you get 29. Then it's the same problem as the last two. Okay, so once you have the base with the unknown, then it's the exact same problem as number 5 and 6. So in order to cancel out this base of 2, we have to take the log base 2 of both sides. When you do that, the log base 2 and the actual base of 2, those cancel. and you're left with the exponent. So you're left with negative 9a is equal to log base 2 of 29. And then the rest is just algebra, where the log base 2 of 29 is almost like a variable. So we divide by negative 9 on both sides. So a will equal log base 2 of 29, all of which will be divided by negative 9. So do not put this negative 9 in the parentheses. That is wrong. Okay. It's a log base 2 of 29. That's some number, and you divide that number by negative 9. So that's the log part, or the solving exponentials with logarithms. Are there any questions on 5, 6, or 7? Okay. Numbers 8 and 9, we want to condense those two equations. In order to do that, we're going to be using the power property, the quotient property, and the product property. Okay. So number 8, just look at what's underlined in red. Okay. We can condense this into log base 2 of 6 to the 4th, because this 4, according to the product or the power property, is really just an exponent of 6. And then the same thing for 5 log base 2 of 5. We can rewrite that as log base 2 of 5 to the 5th. Once they're condensed on their own, then we can use the product property. So what the product property says is that if we are adding 2 logs with the same base, we can combine them into 1 log. So log base 2 of the product of the two things inside parentheses. So this would be log base 2 of 6 to the 4th times 5 to the 5th. And that's it. You don't have to do 6 to the 4th or 5 to the 5th and then multiply those things together. 6 to the 4th times 5 to the 5th. And that's as condensed as that can get. On number 9, similar. The first thing that you should do when you condense logs is to check and see if there's anything in front of each of the logs. Okay, so in number 9, there's nothing in front of the first log or the second log, but there is in front of the third. So the first thing to do is to condense that third part. So the other two stay the same. And this 6 will become the exponent of 11. once you have each one condensed on its own, then you can start to use properties between different logs. So in this case, we have a sum of 3 logs with the same base. So we can put those all in one log and take the product of all 3 of them. Okay, so our answer would be 5 times 6 times 11 to the 6th. All right, and to be honest, you can leave it like that on the quiz, and that'll be fine. Questions on 8 and 9. This is exactly how the quiz will be set up. I'm literally going to hit regenerate, make sure there's nothing that is impossible, and then print it. Yes, you can write it as 30 times 11 to the 6th. The only reason I wrote it as 5 times 6 times 11 to the 6th is so people could actually see what's happening. All right, number 10 and 11 is the exact opposite of what we just did. So instead of condensing, we're expanding. So from these properties, instead of moving left to right, which is what we just did, we're moving right to left. So we've got something that we can expand, and we're trying to condense that as much as we can. Or expand it. Instead of condensing it, we're trying to expand it. All right. I won't give you something that looks like this, but I will make it so you can. And actually, I'm going to rewrite it like this. All right. So in number 10, we have the product of 2 things, or 3 things. So we have the product of A to the 3rd, B to the 3rd, and C. So we can rewrite that as the sum of different logs with C, A, and B in them. So we can rewrite this as log base 7 of C plus log base 7 of A to the 1/3 plus log base 7 of B to the 1/3. Then we ask ourselves, is that as expanded as possible? The answer is no, because these 2 logs have a power in them. All right, so log base 7 of C is as condensed, or is as expanded as it can get. But these second 2 logs have exponents, so we can put them out front. Like so, and then that's as expanded as it can get. And then number 11 is, in my opinion, actually a little bit easier. So we have the product of x to the fifth and y to the third. So we can rewrite this log as log base 2 of x to the fifth plus log base 2 of y cubed. Now that's not as expanded as it can get because there's exponents in here. So we can put those out front. And then we have 5 log base 2 of x plus 3 log base 2 of y. So that's condensing and expanding. The next 5 problems, has to do with condensing and the one-to-one property. So if we can condense equations and use the one-to-one property, this should be pretty straightforward. Obviously, it's going to be a little bit more difficult than either one of them. But if you can do both of them, it should be easy. All right. Number 12 and 13, though, don't involve condensing. Yes, it'll only be 16 questions. All right. Number 12, we're going to use the one-to-one property. So because there's a log base 11 on both sides, they cancel. And then we're just left with 5m minus 3 is equal to 2m. And then we just solve that algebraically. So I would subtract 2m from both sides to get 3m, and then add 3 to both sides to get 3, and then divide both sides by 3 to get m is equal to 1. So again, when there's log base something on both sides, and that's all there is, you just cross out those logs and keep whatever's inside parentheses. All right, so on number 13, there's a log base 9 on this side and a log base 9 of this side, and there's nothing outside of those two logs, so they cancel each other out. So you get 14 is equal to negative 2k plus 7, which is something we should be able to solve very, very easily. All right, I would subtract 7 from both sides, and then divide by negative 2. To get k is equal to 7 over negative 2. So before I scroll down, because it's a little ways down, are there questions about 12 and 13? That is the one-to-one property. So if you could do those first 4, it should be fairly easy to do these 2. There won't be. If there was different bases, then we'd have to use a calculator and switch some things around or change the base, but I'm not going to ask you to do that. Like you could do it, but it's outside of what we've learned and outside of the time that we have. Okay. So these last three are the trickiest, definitely. But if you keep yourself organized and you know how to condense or you know how to use the one-to-one property, you should be able to do this. I will post all of these to on campus with the answer keys. Um, I can make a bank of questions. That's fine. That takes me like 8 seconds to make, and I'll do it as soon as we finish this. There should be a bank of questions on there already, though. And yes, I can check projects early. I won't collect them early. I'll explain how I'm going to collect them tomorrow. Um, and hopefully I'll have a rubric done by then. Okay. Um, Number 14. When you have a problem that looks like this, where you have two logs with the same base is equal to something else, the first thing that you need to do is to condense them. All right. So this is log base 6 of something minus log base 6 of something else. So because of that minus there, we can use the quotient property. So we can condense this into log base 6 of 4x divided by 7. So that's step one, is just to condense something. Step two is to use the inverse property to cancel the log base of 6. In order to cancel the log base of 6, you want to do the inverse of logarithmic. All right, so everything you see here will be the exponent of 6. All right, so we're going to write that as 6 to the power of log base 6 of 4x divided by 7 is equal to 6 to the power of 2. Again, everything that we had in this first line becomes the exponent of 6 in the second line. The reason you do that is because the 6 and the log base 6 cancel. You could, um, but it would make things a lot messier, and it's less organized to do that. So the more organized that you keep this, the better that this is. I would just say this. Just condense it. It's going to make your life a lot easier because you're going to have to do stuff that you won't know how to do. Okay. So when the 6 to the power of log 6 cancel, you're left with 4x divided by 7 is equal to 36. And then you just solve that algebraically. So you multiply by 7. I'll explain why here in a second. Let me solve this first. All right. So 4x will equal to 252. So x will equal 252 divided by 4. All right. So the reason you can't just leave those there um, is because 4x minus 7 is equal to 2 isn't actually our answer. All right, so if you solve that, you would get 4x is equal to 9, so x is equal to 9/4, which does not equal 252 over 4. All right, and the real reason you can't do that is because technically these are exponents. So they don't work the same way as addition and subtraction work. They work on a higher tier. Okay, so treating them like just addition or subtraction um, is just incorrect. We're dealing with exponents, and it's not the same. Okay, so step one is to always just condense it. I guess you could solve it that way, but you wouldn't get 4x minus 7 is equal to 2. You'd get something a little bit crazier. So number 15, again, step one is just to condense. So we get log base 4 of 6 over x minus 6, and you get a quotient because of this subtraction sign here. All right, and then again, we want to cancel out the log base 4. So we need to take this entire line as an exponent of 4. So when we do that, we get 4 to the power of log base 4 of 6 over x minus 6 is equal 4 to the third power. This 4 to the power of log base 4, those cancel. So you're left with 6 over x minus 6 is equal to 4 to the third, which is 64. Then you multiply by x minus 6 on both sides. So you get 6 is equal to 64x minus 384. And again, really big numbers, but that's okay. If we add 384 to just 6, we get 390. And then we divide by 64 on both sides. All right, and I'm happy with this answer. You don't have to simplify or anything. That's totally fine. And then last is number 16. All right, and again, the first step is just to condense those two logarithms. So we get log base 8 of x plus 3 divided by x is equal to 1. In order to cancel out that log base 8, you want to take this entire line as the exponent of 8. When we do that, we get 8 to the power of log 8 of all of this is equal to 8 to the first power. When you do 8 to the power of log 8 of anything, the 8 and the log base of 8 cancel. So you get x plus 3 is over x is equal to 8. And then you have to solve this algebraically. All right. When we do that, In order to get x out of the denominator, we have to multiply both sides by x. Actually, I'm going to do this in a different color so you see what's happening. When you do that, the x's cancel. So you get x plus 3 is equal to 8x. Subtract x on both sides. So 7x will equal 3. And then divide by 7. So 3/7 is your answer. Are there questions about that? Are there questions about anything on this quiz, specifically the last 3? Yeah, so this will post. It's kind of tricky to find for like an hour. What I would do is email yourself this link, and then whenever you click that link, it'll just go directly to this. Okay, and then you can pause, fast forward, rewind, whatever. Um, Tomorrow morning, it should definitely be up just normally, but if you want it for whatever reason tonight, I would save the URL or just never exit this tab. That will work too, but that's kind of weird. There's also the review that I did Sunday night. So there is already something like this up on the channel. Um, I definitely didn't go. I probably didn't take as much time on this on one test, but it's still up if you want to watch it. You can always pause and try and do those problems on your own, and then press play and then see how I did it. So I'm going to leave this up for the next like 10 minutes or so. And as you guys have questions, just ask. But I'll plan to end this at, let's say 9:56 unless people have questions. 9:06, not 9:56, 9:06. All right. Since there are no other questions, I'm gonna end it here. Um, I will post the two practice quizzes that we did in on campus along with their answer keys. Um, Hopefully one with their answer key. I don't know if I can find that, but I'll definitely post this one. And then I'll post a bank of questions like them. All right, so I'll post just a massive quiz. So probably double or triple in length that are just similar questions. All right. Um, so that's all. Have a good night and thank you.